everyone. I'm pretty excited. It's time for another DraftPhysics.com, DebatePhysics.com also. Video presentation. Yay. So, comments mostly, probably. But I figured I'd take on a couple of other little subjects. Yeah, well, I might as well do the comments and then do the subjects. Part of me wants to explain, certain. I guess it's just the idea of time and how important it plays a role in the migration of energy. And so, the argument with the Earth is that it's constantly radiating. It's at some sort of equilibrium. That it's constantly radiating the same amount that goes into the Earth. But the point is that you still have to account for the fact that it's always a little behind, because the stuff that radiates out of the Earth, a lot of it has to go through the Earth to radiate out of the Earth. So it's always a little bit behind. So it's like you could drop something and there's going to be a counter force that will equalize what you did. But the fact is the counter force doesn't show up till another one of the other things is coming in. So it could appear that you compensate for the one coming in, but the truth is this one's compensating for this one. And so you're still one behind. And you just end up always one behind because of just the fact that it takes longer for energy to get out than it takes for the energy coming in. And so the counter reaction is always a little behind. So this sort of gets to the heat engine stuff. And, it's unfortunate, the last two videos I made, I probably shouldn't got into any of the technicals regarding how those heat engines work, because I was just assuming they were a bit simpler than they really are. And, that was my bad. Because there's little places where the real action is and places where it looks like there's action, but it's really just doing something completely kind of fake. And but the surprising thing is I saw a guy who the video's called like the smallest heat engine, and it's mostly a video about him milling the parts. So you have to really appreciate that kind of process. I mean, these tiny little, he's a watchmaker or something, so he has the hardware to do that. So he made a very small one. And I don't know how efficient it is in terms of how much heat he needs to make it run, but he could make it run very fast. And that's the part that's not intuitive, because I think of heat as something that moves relatively slowly, and it seems incredible that you could possibly create heat differentials, where you could have 50 cycles or 60 or 100 cycles a second. Seems very unrealistic. I think the actual number, it's going to be 20 or something. So there is a limitation to how fast you can change the temperature of air and get anything to happen out of it. But it is surprising. So part of the way I'm, to understand some of it is to understand that the cylinder itself is going to absorb energy. And so the cylinders are actually made to radiate some heat. And so part of the equation is that what you're doing is just in the one example that was in Steve Mold's, the whole foam thing is sort of a dodge. It's not a real cylinder. All it's doing is pushing. It doesn't tightly fit, so it's pushing air from the bottom to the top and vice versa. So it's just an air pusher. So it's just forcing the air to move from one side of the foam to the other side of the foam, essentially. And so it sort of fools you. It's not really. It's the work cycle. The work cycle is moving this displacer, as they call it, to force the change in the air in the cylinder itself. But anyway, so the point would be is you could just think of you put a couple of units of heat in here, it pushes the cylinder. Well, that means the heat had to go into the cylinder as motion, momentum. And then the added feature is that, because the cylinder is a dense material and it's cold, it also absorbed some of the energy. So it took some of the heat also. So now it started off +2, let's say, and now it's -3. And that's why it contracts, is because now the air is -3 because it gave away too much. And now it's in a deficit. And so that's the vacuum sort of pressure that's really doing half the work. So, part of the work is really the vacuum part, not the expansion part. And so that's the function of this displacer, is once this air is now colder than you want to push this down and push the hot air back in and redo the cycle. So you're just really exchanging this air. So once this air gets cold, you're taking it out and reheating it and then bringing it back up. And it's just amazing how quickly you can run that cycle. It just surprises me how fast these temperatures can change enough to cause this action. But anyway, so it's a sort of a technical argument. It doesn't really have anything to do with the basic argument that this perfect engine is just really just saying you can move heat back and forth, and you could do that forever theoretically, but they won't do any work. And as soon as you do any work with the engine, then it has to lose energy. But the irony of this whole conversation is they're using these heat engines in a video where they're saying heat is useless. So that's the irony of it, right? Is they're saying heat is useless. And what they really want to say is, for human beings, it's useless if we don't have a whole bunch of extra. So it's like we need to account for all the waste, and so we want something that's really direct, but we don't want to deal with the waste. So it's like nuclear power, right? So you're taking this nuclear power thing, this explosion, and you're saying, what do we convert it into? Oh, we convert it, this explosion in terms of the radiation. What do we convert the radiation into? Heat. And then we take the heat and only use a portion of it because, we want the extreme part is easy to collect, extreme differentials. But the smaller the differential gets, the harder it gets to create energy that's, powerful. So we take just the powerful part, just like in a gasoline engine, you take the powerful explosion and then you just pump all the heat out. So you have all these high temperatures, you have lots of hot gas, and you just shoot it out the exhaust pipe because you're really not interested. It's too much work, too much time it takes to get that heat to actually do some work. So you just throw it out. So this isn't about heat, it's about heat from a human use perspective. And like I said, it's just kind of a huge irony that all of the ways that we take heat from oil even is still through converting the oil into heat and then using the heat. And in nuclear power plants you can see the huge waste. They have those evaporating towers. They're not smokestacks, they're just giant evaporating towers. It's because their water is still a couple hundred degrees and it's not hot enough for them to do what they want to do with it, so they just waste it. And before they can dump it in the environment, they got to let it cool. So it's just a place for the water to cool so they can dump it. But it's obviously you could apply a little bit of technology and excrete a lot more heat, a lot more energy out of that heat. It's just that we don't want to spend the money to do it that way. It's cheaper just to take the big, huge differential and take a little bit of it than it is to try to take all of the differential. And so it's just a bias of humans that they're going to say something is useless when it's just as useful, it's just as real in terms of it being energy. You just don't like that you have to construct some tools or instruments to be able to collect it. And that's what it's really about. So anyway, this whole argument just seems so imbecilic, to be arguing that somehow the universe is demonstrating that it's falling apart when they'll show you galactic pictures of suns being created. What's the point of telling me that it's all falling apart when there's every indication that it takes the little pieces and puts them back together again all the time? And so it's just a bullshit argument. And then even if the universe was expanding, which I don't think there's any reason to believe it actually is, and you were going to argue that, see, they say gravity is bent space. So if I only had one planet in the universe, would their theory say it still has gravity? I mean, I don't know. Does bent space disappear? So obviously, from my point of view, if I just had one planet and I didn't have any force, that is, no radiation coming from any sources, I would argue that there wouldn't be any gravity because there's no radiation to force things together. But I'd also argue that if I had some Earth I placed in that condition and I gradually cooled it, just to be fair, if I gradually cooled it, there's no force that's going to blow it apart either. So even if the universe was drifting, you would still have plenty of clumps. Okay, it wouldn't all disperse into infrared radiation. You'd still have plenty of clumps of matter. And if gravity was still existed, then you'd still have a viable planet in the sense that, okay, you wouldn't have any sunlight, but you'd have plenty of thermal energy being created by the gravity. And so you just build yourself a civilization underground. You create synthetic lighting and you create all that, and it's completely doable. But anyway, just saying, their argument is, there's so many of their arguments that are just so wrong and so obviously wrong, like 25 times the fuel to go 5 times as fast. And you're just saying, why are they making them? Because they're just so easily proven to be nonsense. And it's just nonsense to say there's some entropy tendency, that in our universe matter is falling apart more than it's collecting. Where's the evidence that that's happening? So again, there's a deeper argument, where you could just argue, well, if it was a finite universe, what happens to the photons that leave? So that would be a viable place for us to lose energy. But that energy, right, would be a leaking of something smaller than heat, okay, in terms of it's all just radiant. It's all just photons. It's not matter. So the universe wouldn't be excreting matter. It'd just be excreting photons. And so it would have to get colder and colder and colder by my theory. Now, by your bent space theory, again, you have lots of sources of thermal energy from the gravity creating all this pressure inside of everything that's big. I'm just saying, there's just absolutely, it's like they've never drawn it, they've never thought about it. They just make up this crap, and it's just it's got such obvious defects. This is like a drawing of a tree, and they have the roots going out the side, and branches going straight down, and it has all kinds of completely nonsensical inconsistencies with what we know reality's doing. All right, so I should be able to just find comments here somewhere. All right, and well, I guess I should try to post them for your benefit. So maybe pause and do that. All right, should be back. All right, air in a balloon is not spread out. So kind of obviously all the physicists know, so I shouldn't have to say that the air is going in all directions. The energy in the balloon has vectors in all 360 spherical degrees. So it's clearly spread out in the sense that all of its vectors are in all kinds of directions, not one direction. So the vectors aren't in parallel at all. It's not a stream flowing through a confinement. It's a splash, okay? And the argument is that, yes, the very point I was making is that you can put this divergent pressure inside of a collector, and then you can force it to come out one way and collect coherent energy, momentum, in an object. And that's a way of converting the divergent energy into convergent, or at least culminated energy that's much more useful That was the whole point of the illustration. The fact is, the energy in the balloon has high entropy. It's collected inside the balloon. So it just doesn't change that the energy itself has high entropy. Oh, God. I mean, it's just so stupid. All right. But how is the heated air from the bottom plate getting to the piston through the foam of the if the foam is acting like an insulator? So I don't think I said it was an insulator, but I might have. Okay, let's just forget it. It's not an insulator. Okay, the foam is just there to create a light cylinder. And again, it's not really it's just to displace air. So its intention is not to be airtight. Its intention is merely to change the direction the air is moving. All right, so I explained that the bottom cylinder is kind of a red herring. Its only purpose is to turn off and turn on the heat. So in a sense, that's what the displacer is doing, is taking the hot air on the plate and pushing it up to the top, and then taking the cold air and pushing it onto the hot plate, and then taking the hot air and pushing it up to the... So it's just moving the air. So it's moving the hot air up, and then because convection would be way too slow, so it's moving the hot air up and pushing the cold air down. All right. So you don't believe in the second law of thermodynamics, not as a universal statement. So there's two interpretations. Apparently, what was the guy's name? Bose? Not Bose. Well, some B name, I think. Anyway, Bozeman? Maybe. Has another definition of thermodynamics that just has to do with all the probability stuff. So the crap about the fact that, you pour ink into a bottle and it mixes in a certain way and you're not going to be able to extract it back out because the fact is randomized, and there's, you're stuck with the fact that now it's too dispersed. And that's a different theory than the original theory that had to do with caloric and heat, and is just talking about some kind of idea that energy, okay, has this progression to become more discrete and smaller in a way. And again, the point is that, of course, obviously, in my opinion, gravity is the counter mechanism. It's recharging the batteries. Yes, batteries discharge, then they're recharged through gravity. You take the same pressure you released in all directions, and because we have a gigantic universe, all directions mean you're inevitably going to hit another piece of matter and compress it. So the force you give off is the force that compresses somebody else. So it's a cycle of compression and expansion, compression and expansion. And there's no evidence that one is happening more than the other, or that one is easier to tap than the other. All you care about is the movement. You don't care. It doesn't make any difference whether you're capturing it when it explodes or you're capturing it when it collapses into a sun. The gravity of the sun is the same capture as the exploding nova. Also, you can't understand the universe tends towards disorder. I can't see any reason to believe it. Okay, there's no evidence of it. You can't look at the universe and say, oh, I see the disorder that's happening, because you see a bunch of things creating order. Things that look pretty ordered, like a galaxy. That's not the definition of disorder. Now, I sort of speculate that galaxies are, in fact, collapsing and expanding. So, depending on when you're looking at one, it's either in the state of falling apart or it's in the state of coalescing. But anyway, please explain how gravity isn't defeating entropy. Okay, so he says, when things form in space, whether that's black holes, stars, etc., tremendous amounts of energy is released and dissipated. So he's saying when you condense a star, you release energy. When the obvious point is you're doing exactly the opposite. You're condensing it. You're creating heat. You're creating pressure, which is heat. You can't really do one without the other, right? So if all this weight, you know, me, and then the dirt under me, and then the dirt under that, and then the rocks under that, and the water under that, and the rocks and the water and the rocks and the rocks and the rocks, all of that crap is sitting on top of the center of the earth, and it's compressing the fuck out of it. So it's all momentum. Momentum given to things, given to matter by gravity. Right now I have a momentum into the earth. I am applying a constant pressure to the earth. And it's just ridiculous for you to say that's giving energy away. No, it isn't. Oh, God. You know, it's just so bad. Anyway. Entropy still increases. So he's saying entropy increases when a star is formed. So you consolidate a bunch of moving matter and the force to push it into each other, the momentum you give it, and you push that into a little ball, and he says that increased entropy. When obviously it did exactly the opposite. I mean, just this is just so goofy and stupid. You're just like, what the fuck? I should have to argue with nonsense this ridiculous? All right, entropy still increases even with gravity. So I don't know if there's a physicist that would actually say something that's stupid. But I mean, it's insanely stupid. All right, gravity does not reduce entropy nor disprove it. So he actually believes that somehow consolidating matter into dense, hot objects is not reducing entropy. Amazing. So anyway, it's just amazing. In order to have things be created, energy still needs to be spread out and released, increasing entropy. So he really sees no other part to the cycle. The cycle is things just expand and get bigger, and nothing ever contracts and gets smaller. That's his understanding of how the universe works. Pathetic. Okay, so I say gravity does not reduce entropy. That's his statement. So matter converging under pressure, creating high densities of matter and heat, doesn't reduce entropy. I think you're not even stupid. So anyway. I think you have a misunderstanding of entropy. So amazing. You know, entropy increasing over time is a law that pertains to the whole universe. So again, you know, that's the part. Again, that's the part that's so obviously wrong. You know, the idea that ink diffuses into a fluid, that's correct. Okay, that the more permutations, the harder it is to ever, you know, if I have 5,000 dice, the odds of me rolling, you know, 5,000, well, 2,500 snake eyes, is preposterously small. Okay. Anyway, something converging under gravity might reduce entropy. So now he's saying it might. Oh, he might. It might reduce it. So his emphatic statement from above, oh yeah, well, that was just shit talk. So okay, he's refined it. It might reduce entropy. For a local system, I mean, what? There's no local. We're talking about the whole universe. Is the whole universe now less entropic, okay, when there's a sun rather than a bunch of diffused energy? Of course, it's more less entropic. Okay, it's by definition, the whole definition of the word. It is now less entropy when you make the sun into one thing rather than 6 million little things. But the heat radiation released is still still contributes to the increasing entropy of the universe. You'd have to be making energy for there to be an increase in the entropy. Energy can't be in both places. It can't be in the hot core of the earth and pretend it's also still in space. That's the whole point of the idea of the consolidation of the matter, is that it's taking all of these atoms that are also pressurized and all this pressure. And that's why suns can burn for billions of years, is for this very reason, that the contact, they're under such extreme pressure. That's the only way the thing can work. Oh, God. And all that pressure can't be in two places at once. It can't be out there in the universe and then smashing atoms together inside of a sun. All right. Obviously, I think you misunderstand, especially in the context of the whole universe. When the sun releases energy, what do you think happens to it? My argument is that the energy will inevitably hit something else and add to the mass and compression of that something. So it obviously will end up charging a battery somewhere else. So you release the energy in one place, you will collect it in another place and store it, and then you'll release it again, and then you'll collect it and store it, and then you'll release it again, and then you'll collect it and store it. Just like the atoms that make up the Earth were flung all over the place. Now, I'm not too sure about how far they were flung, right? Because you could argue that the sun is just a remaking of something that exploded, and it's all just a local event. But clearly it has less entropy when it's not exploded, when it's clumpy. You know, your argument is premised on some unproven axiom that more suns are dying than suns being created. So obviously that's all you have to believe, is one or the other, right? I could argue, oh no, there's more suns being created and the whole universe is going to collapse. Or you could argue that no, there's a few more suns, they're dying a little bit faster than they're being created, and therefore the universe will get cold. Sort of. Maybe. Again, it depends. I mean, again, if you don't understand gravity as being one of the forces that are real and that it's really made out of energy, that gravity gives things momentum. Well, how does it give things momentum? Because it has to have momentum. Things that don't have momentum can't give momentum. So obviously that's a break in the energy cycle when you say gravity is some other source of momentum, some other source of heat and radiation. Okay, until you prove that, you have no reason to believe the universe is becoming less clumpy. Alright, so the asshole says, look, I'm going to be honest with you. I didn't see your channel till today. So that's my fault. That's my problem? No, it isn't. And you have a lot of misunderstandings about certain physics topics. Yes, says you with no reasonable arguments. You just made a bunch of nonsense arguments. First you say, gravity doesn't change entropy, and then you say, well, maybe gravity changes entropy. I mean, you're the one showing you're full of shit, asshole. Okay. I'm going to stop commenting. I'm so disappointed. But please go on and actually try to understand these concepts. So I'll argue that I could beat the shit out of you in a physics test, moron. So what's the point of this? You can't make a reasoned argument, and all you're going to do is shit talk. You fucking useless sack of crap. I mean, get what you fucking deserve, which we're all getting, but you know, they are fascinating. Whatever this is. So to you, this is all some sort of fascinating thing. Oh, it's so fascinating. Yeah, I love playing with physics, Wiener. You don't take the truth seriously, right? It's not something that means anything, does it? Okay, fuckers. Physics is one of the most rigorously proven scientific fields of study. So they haven't even dropped 4 pounds 1 foot and 1 pound drop 4 feet to prove one of their fundamental axioms, that those are equal amounts of energy. They haven't even done that. And then we have all the other superfluous, amounts of evidence. The lever proving mv squared is nonsense because the lever can't find it anywhere. And, the Mythbusters did crash the cars. No evidence of 4 times the damage at twice the speed. Absolutely no evidence of it. I mean, no indication at all. Okay. But it's proven theory. Yeah, we proved it takes 25 times the fuel to go 5 times as fast. Yep, we proved it over and over again. No, you didn't prove shit. You're just such liars. I mean, to say this rigorously proven scientific fields is amazing. The proof is non-existent. You haven't even done the Eddington experiment from fucking space. 400 times better resolution. A 5-minute fucking experiment. You haven't done it. All right, anyway, rigorously proven scientific field of study. I mean, this is a lie, right? I mean, this is just such a grotesque lie. You're just saying, why would they resort to such grotesque lies? This is flat earth dishonesty. Okay. And I think you generally are interested in it. Yeah, please go fuck yourself till you're good and fucking dead. All right, please go and be open-minded. So again, I was open-minded. I tried to make some sense out of this gibberish, and I found that, oh, it's all, I went and researched it as. So go ahead and research MV squared. You're defending a theory invented by a guy who believed in solitons. That means, matter has souls, and monads, whatever the fuck a monad would be. That's like an underling of a soliton. And it's all some sort of, divinity thing. The matter is striving to be divine. That's the crap you're defending, fuckface. I bet you do have a fucked up face. This is an asshole who steals Clint Eastwood's image. It's probably Farley. Okay, anyway. And go read textbooks. Yeah, go fuck you. I've played hundreds of college physics lectures on this channel. Fuck you. Physics is not easy. Fuck you. It's really simple if you take your shit off of it. Your shit is what's made a mess out of it. But it's very rewarding once you grasp it. Oh, fuck you. What have you grasped? Photons are doing this and this because they're very, very flexible. But stop peddling the idea that it's a religion. I'm not peddling it, I'm proving it. And you're proving it. Your preposterous exaggeration of the level of certainty you have created in the evidential record, your preposterous lies about that evidence. Again, where is your evidence? What's your go-to piece of evidence for the existence of 1/2 mv squared? Because every fucking experiment demonstrates it's a pile of shit. 2,000 joules of energy go into the ballistic pendulum, and you can only collect 2? 2? That's the best we can do with all of our technology. Yes, we land on the moon, but we can't collect 2,000 joules of energy. We can only collect 2. Fuck you. Alright, if you are someone who doesn't even grasp basic kinetic energy work or the kinematics, then don't talk about entropy. Yeah, well, fuck you. You're the one that has it all fucking wrong, and you're a fucking disgraceful liar to say you have any evidence. Okay. You need to take a long look at what you're putting out there. You need to take it that same look. Just get what you fucking deserve. I mean, I can't wish anything more for you than you get exactly what you deserve, you lying, shit-talking, fucking piece of shit. You're the garbage that ruins civilizations. Please just take my advice. Fuck you. Hard and unpleasantly. All right. Anyway, so this is something called a zitteron. It's probably more like a zit. Anyway, don't be so offended. This guy has been at it for years. And yes, and you've demonstrated your community to be full of cowards. They can't make a counter argument. They can't make a single fucking video playing one of my 5-minute videos and explaining how I'm making outrageous errors in my analysis. They can't fucking do it. Even for thousands of dollars, they won't do it. Because they're fucking petty cowards. And I don't think I've seen him do a single equation. So again, what equations do I need to do exactly? What equation do I need? So I have said, MGT. That's an equation. Okay. I have said work is distance is force times time, not force times distance. And of course, I've said mv is energy, and mv is weight, and mv is heat, and mv is everything. Everything is just momentum. Momentum is the only thing happening in the universe. The motion of the matter is momentum. Even when it's oscillating, that's momentum. It's all just momentum. The force has it. The force then gives it to the matter, and it's that simple. With calculus, no formal mystery of classical mechanics. It's just vibes. So what a pile of crap. It's drawings which you're not capable of. So why don't you draw me a picture of how you think an atom works, and shove in the 400 bullshit particles that physics says is in there somewhere. So show me where the positrons are hiding. Show me where the the anti-electron is. What do they call that? Show me. Well, the anti-electron would be the positron, and the anti-proton is a fuckton. I don't know. All right, you people are just such scum. All right, and then so this asshole says whatever this is, K-O-fan. He won't take your advice. So again, I've played hundreds of physics lectures, been as fair as I can be in terms of providing my arguments. Cut them to 5 minutes for fuck's sake. Just because I guess you're all too fucking lazy to do anything more, and you still can't make a counter argument. This guy has been nutty for Jean Ray for more than a decade. Has been nutty as. So these are always people that seem to know who nuts are. So apparently they watch nut videos. I can honestly state on, the life of anything I care about. What's a Jean Ray? Why should I give a fuck about a Jean Ray, whatever the fuck that is? Why do you give a fuck? That would be the good question. Oh, these people are just so fucking pathetically shitty as human beings. So anyway, just get rid of them. There's no point in talking to scum. Lying scum. Disgraceful, lying, sacks of shit, scum. Alright, so I was excited to see this, but following them both for a long time, I would say they are polar opposites of the physics redo. I still believe there's a chance Eric is a troll. So that was the Eric Weinstein, and then previous was Weinstein against Wolfram. And so I looked into Wolfram's theory a little bit more. First, he won't disclose anything, but it's just bullshit. I mean, the level of bullshit is just so extreme. You just can't even. He has all these weird names for everything. A ruledom, a ruleyard. Yeah, ruleyard. Yeah, we're living in a ruleyard. Oh, god damn. Alright, anyway, no need to apologize for laughing out loud. I did as well. Yeah, it's just so bad. I think your theory is viable. I can only be a push universe. Well, that one should be easy, right? I mean, it's just so... Again, you're just sitting here saying to yourself, they won't even say those words. That push makes 100% reasonable cognitive resolution. I can see the idea of a push. I can visualize it. I can visualize the function of one thing banging into another. How do I visualize a pole? Oh yeah, magic. There's no way to do it. There's no mechanical way to have a pole. Okay, unless you create a pushing force, and just remove the push. Okay. It's the only thing that makes logical sense. Yes, it's just so obvious and so true and just so disappointing. Let's see. Hey, Gary, listen, I'm not a physicist. I'm just open-minded, capable of critical thinking. I love your force. Is it possible there's just one force? Oh, yeah, so I did answer this by just saying, well, I spent years trying to do it, but it doesn't seem to me that you can make something that's one thing and then make an electron and then make a proton see it differently. You get it? I mean, how could the two players be able to tell the difference? So if I turned it sideways or I turned it this way, how could I see a difference for those two things without, there's no way I could turn this at an angle, because the protons and the electrons see the same thing no matter what angle they're viewing it from. So I can't, there's really just no way to say the same thing can be seen differently. I mean that I can make the same thing look different at a different time. Like when it's over here, it looks this way, and when it's over here, it looks some other way to a proton. I can't make a proton that can do that. I mean, I can't make a thing that does that. So there has to be two kinds of this for the proton to react to the two things that have similarities but are distinctly different. So the two forces just fixed everything. I mean, that's a simple answer. I mean, it makes the thing work. And so once it's working, why would I care? All right, so maybe I'll throw a little tiny bit of that in here as context. Just another little glimmer at the simulation, just to prove my point. These people, these cranks, talking this shit about what I know, and I'm the one that's simulating charge, not physics. I am. They can't do it. I can do it. Alright, so big version. Yeah, so obviously what's happening is, as you'll see, it's red, green, but yes, they are all kind of smashed onto the sides. So I'll play around with it a little bit, and we'll change these radii, and that'll help get things moving about a little more. And then we could always add another. Whoa, that was a really big force bit. Yeah, that's really big. Let's see, smaller. There we go. And let's. What do I want to do here? I want to green red matter bits. Yeah, that's it. If I change one of these, it should create more or less. Yeah, there we go. So they're in new positions. But yes, they will combine and do what they're supposed to do. And if I increase the force, it becomes more obvious. In terms of, and I got to increase their velocity a little bit. So yeah, their masses, the green mass is a little too big and such. But anyway, you'll see the idea. So I think you can see, yeah, you can see that. This is half of a helium nucleus right here. And so all I have to do is get two of those to line up, and then I'll have a helium nucleus. And then I can deal with maybe the drag subject in terms of demonstrating why helium nucleuses can continue to travel through space uninterrupted, and electrons and protons and neutrons, which, there's a neutron over here. Yeah, can't do. So anyway, but yes, simple little rules, right? Two kinds of force, two kinds of matter, three kinds of interaction: absorption, reflection, and conversion of color. And so obviously I don't think neutrons and electrons protons and electrons are colored. I'm just saying they obviously have a feature that makes them able to identify each other, and that's all that needs to exist. But it's perfectly duplicating what you would expect of charged objects in a random field to do. This is what charges will do. If you put charges in space, this is what they will do. And the fact that they do it with a little bit of chaos just demonstrates the fact that that's what defines the stability, is that everything is in a tension. Anyway, so yeah, fuck you to these people who say I don't know what I'm talking about. I couldn't have invented that if I don't know what I'm talking about. Fuck. I mean, it's just so dishonest. I mean, if anybody else created this simulation, people would be going, wow, that's incredible. Those simple rules, and it works. We've got to think about that. Because, yeah, that's pretty simple, and it works. It's duplicating something physics can't explain. It's showing a physical mechanism explaining why electrons and protons behave the way they behave. All right. A really simple physical mechanism. All right.